In this program, we were required to do a bubble sort implementation and specifically to display each pass of the sort. So you will be able to see how the array changes. I added this line in the nested loop so that you can see what the value of I and j is at each point when it goes through the loop, as well as the array at that stage. You will see how this array changes as the bubble sort is executed. Let's test it. There's the original array, and you can see in a nested loop the I stays the same, goes through all the values up to the second last one, and then compare with every element next to it on the right hand side of it. The elements are swapped so that the biggest one after the first loop with I, first value of I, then the biggest one will be in the last position, or in the correct position. Then you go from the second element and compare to the rest of the array, and now the last two elements will be in the right position. And then when I is 2, you compare it to the next two, and finally the whole array is sorted. This activity required a linear search to create a function that performs a linear search on a list to find the index where a particular value is, if at all. I declared the function receiving the array and what to look for, and I declared a little variable -1, so the position is therefore -1 unless you actually find it and replace R with the index. So if you return -1, it implies you never found a match, and if you do find it, R will be a new value and you will return that value of the index. So if you look at this array of 6 values and you print all the values and then you ask which number to search for, the program will call the function with the user input, and then if you receive that -1, it means the number was not found, and if it's not -1, it will display the position, either the index, which starts from 0, or the position, which starts from 1. So let's test the program. So if you enter a number that is not in the list, let's say 25, it will say the number not found in the list. And if I run it again and I look for, say, a 72, was found in index 2, 0, 1, 2, or position 3. The instruction for this activity was to use basic data analysis with Pandas. I used student names and their marks, and then I displayed the data frame with some basic statistics. I used average, or the mean, and I used the maximum, and I used the minimum, and then the range is the difference between the maximum and the minimum. And the data frame will display nicely in a table. Let's run this one. In this activity, we visualize data with Matplotlib. I imported the package, and then the subjects I chose, and in South Africa we all do Afrikaans and English, and then I added 3 more subjects and marks for these subjects, and then I used the bar method. The example had a line chart, and I had to Google how to use the bar chart. I made it purple. It's the names of the 2 lists here that you actually put in this bar chart. Then your X and Y labels will appear. The title for the graph will appear, and then you'll see what it looks like. In this program, we demonstrate simple NumPy operations to create an array and then perform basic operations like sum, average, size of the array, maximum, minimum, and to reshape the array as a matrix with groups or columns and rows. So I created an array with 9 values, basically to fit the 3 by 3 matrix, and then I used the various operations available in NumPy to display the array, to calculate the sum of the array, and I displayed it with a label, then the average or the mean, the size of the array, the number of elements in the array, then that's the maximum value in the array. In this case it looks like 97, and then the array reshaped, you'll see when we execute it. Let's test it. So there's the array listed, the sum, the average, the size of the array is the 9 elements, the biggest and the smallest value, and then the array reshaped as a 3 by 3 matrix with square brackets around each row.